Hello, I'm Andy Cobley. I worked on the GROW Observatory EU project. Welcome to this introduction to the GROW soil moisture dataset. This is available from the We Observe marketplace. Just follow the links and you should be able to get to a page where you can download the data. The data in this dataset was recorded over 3 years from around 6,500 soil moisture sensors. If you go to the growobservatory.org website, you'll be able to find a tab that will lead you to a plot of the data. Let's have a quick look at that now. So this is a map of all the soil locations, sensors locations. Missing off this map are ones that are in error, so you will find there are some which have a soil location of 0, 0, but we've not placed them on this map. Also note that these sensors down here in Africa are misplaced. In other words, they're not there, they've probably got their latitude and longitude mixed up. But you can see on the map there's a large number of locations. You've got Portugal, UK, Austria, Greece, Italy, etc, etc. And you can zoom in as far as you want if you wish to. Let's just zoom into Scotland. There we go. Also on these graphs you'll find other information. So this is when the sensors were added. Obviously the sensors can't be added all at once. And this one indicates when the sensors were last read. We've got a large number that were read in the last 3 or 4 months of the project and a small number that was sort of read a very long time ago. Okay, so we're going to have a look in a second actually at the data set. Now, as I say, they're really quite big, some of these files. So you'll probably have to work with them programmatically rather than opening them in Excel. You probably won't be able to open 14 gigabytes in Excel. So what I've done is I've fired up a virtual machine in the cloud and I've downloaded the data to there. It's a Linux machine, and this will allow me to actually have a look at the data without overloading my little laptop. Okay, so here we are on the cloud machine. I'll just have a look at the files that we have. There are 2 files, locations.csv, and that's 8.1 megabytes, and timeseries.csv, which is about 15 gigabytes. The locations file contains a list of all the sensors and what location they are in, whereas the time series file has recordings of the actual data. So, what you'll find in both these files is that there's actually a lot of repeated data. That is data that is it's making extra space, shall we say. Now, normally what I'd do is I would read these files into a SQL database, and from there you could start to join them together and normalize them and start doing some proper work. Also with these time series files, I have used the R programming language to evaluate what's in them, and that seems to work fine, and I suspect that Python would be brilliant as well. Okay, let's have a look at the first file. I'm just going to use the more command to look at the top of this file. Here we are. So the very first column is the serial number. Now each sensor has a unique serial number. There's then the longitude and latitude. There's then a fairly long name for the sensor type. Now this is in many ways historical from the way that the databases were set up for GROW. So Thingful connectors, GROW sensors, we don't need to worry about, but we can see after that we've got air temperature, battery level, fertilizer level, light level, soil moisture, and water tank level. Now, 2 of these you don't need to worry about. The water tank level is for a particular product that was similar to the GROW sensor from Parrot, and it had a watering tank. Now, we weren't using them, so that level's never there. The other one you can probably ignore is this fertilizer level. We found it to be a little inaccurate, and we never used it ourselves. The next word in here is flower power. That's always going to be the same. And then there's grow, thing for sensors, and a number. Now this was an internal number that again you probably don't need to worry about. Finally, there are two timestamps. The first is when the readings were first taken, and the second is when the readings were last taken for that particular sensor. What you'll note is that for each of the four, each sensor is actually named 4 times. So for this one that ends in 5142, you can see that it's got a line for the air temperature, for the battery level, fertilizer, soil, etc. So when you're working with this data, you're probably going to want to compress this down in some way. Okay. So that's a look at the locations file. And from that, you should be able to plot the locations of all the sensors. What's much more interesting is when you start adding the time series. Now, what you can do is the time series and the locations file are both linked by the serial number. So let's have a look at the time series file. Okay, it's a bit simpler. So the first line is the serial number. The next one is that internal location number, which you can use if you want. There is then what you're actually reading. So here we're reading the battery level. The next line is the value of it. The next column is the value. So here it's 100. And then there is a timestamp for that reading. Okay. So these sensors read data every 15 minutes. So the first one was at 10 past 1. The next one was at 26 minutes past, 41 minutes past, 56, etc., etc. And then you'll find that it moves on for that one to the soil moisture readings, battery level, air temperature, etc. Notice also that that sensor number there changes. That's for a different sensor. So you'll have to be careful when linking this to the locations file through this serial number. The two files are very simple, but they contain a wealth of information that I'm sure you'll be able to get some very interesting projects out of, especially when you combine with other data, perhaps weather data from your local Met Office, air pollution levels, etc., etc. It's up to you. Thank you for listening.